The Eva and Petra show.
Wow, wow.
Eva, that's enough. Okay, so today we are going to learn how to find the inverse of 3x3 matrices.
Let's go to a new page.
Sorry, hold on. Okay, so we're going to call our matrix A. So Eva, write A equals matrix -1, 0, 2, 3, 1, 0, 1, 0, -3.
Okay, so the equation we're trying to accomplish to find A inverse of A is A inverse equals 1 over determinant A times the adjoint of A. To get our adjoint, we have to find the determinant of the 2x2s. So we'll show you how to do that. Okay, so let's switch colors here. Okay, so let's put some new brackets. Okay, so if you... Oh, that's big. Sorry, let me use a different, smaller. Okay. So if you circle 1 and cross out the rows and columns, this is your new matrix. So it's going to be 1, 0, 0, -3. And if we continue doing that throughout the rows, the corresponding row and column become that matrix for each spot. So 3, 0. Oh, dang it. Sorry, having issues. Dang it. Okay, 3, 0, 1, -3. So you can just continue doing that.
Okay, so now that we have found all of the 2x2 matrices, we now have to find the determinant of each of these matrices, which will be called the matrix of minors. So that matrix equals, so the determinant of this first matrix, this one, is equal to 1 times -3, which is -3, minus 0 times 0, which is 0. So that would be -3. And then this next one is 3 times 3, -3, which is -9, minus 1 times 0, which is which is 0. So that would be -9. And you continue doing this for each 2x2 matrix. So now that we found our matrix of minors, which is this, we now have to put that into the matrix of cofactors. So let me make a new page. Okay, so to put, So let's bring our matrix of minors back over onto this page. So let's restart fresh. A equals -3, -9, -1, 0, 1, 0, -2, -6, -1.
Okay, so now that we have that, we can put it into our matrix of cofactors, which follows this rule. Let's put in a different color. Positive, negative, positive, negative, positive, negative, positive, negative, positive. So matrix of cofactors. So for each positive, it's like it is the same as multiplying by +1, and each negative is like multiplying by -1. So if we follow this rule, we get -3, 9, -1, 0, 1, 0, -2, 6, and -1.
So now we have to change it into the adjoint. So to change the matrix of cofactors into the adjoint, you keep only the diagonal the same. So only the -3, the 1, and the -1. And then you flip everything else around. So it would look like this. So -3, 0 and 9 switch, 1, -1 and 2 switch, 6 and 0 switch, and -1 stays the same. So that is the adjoint for A.
Lastly, we have to find the determinant, and let's bring this matrix over to our new page and copy it back down, which is
-3,
-3,
0,
0,
-2,
-2,
9,
9,
1,
1,
6,
6,
-1,
-1,
0,
0,
-1.
-1. Okay. So, if we go back, if we remember from our first page that
Our original matrix?
our original matrix is, let's clear this. So if our original matrix is -1, 0, 2, 2. I can't write it. 2, 3, 1, 0, 1, 0, -3. So we have to find the determinant of this, because if you remember, or we have to find the determinant of A, because if we remember, our equation was the inverse of A equals 1 over determinant A times adjoint of A. So, to find the determinant of matrix A, we have to go back to what we did in the beginning, where we do one expansion by minors. So if we find one, we cross out the wrong column, and we get our matrix. Except this time we're going to be multiplying by the one factor in the corner. So let's go back. Determinant A equals -1 times the determinant of 1, 0, 0, -3 minus, because you always because you have to follow the matrix of cofactors, which is adding, subtracting, adding in the top row. Then we do 0 multiplied by 3, the determinant of 3, 0, 1, -3, plus 2 multiplied by the determinant of 3, 1, 1, 0. So if we simplify this, we get -1 times 3 times 1 minus 0 times 0, which is -3. -3 minus, well, for this one, we don't even have to find it because 0 times anything is 0, plus 2 times 3 times 0, which is 0, minus 1, which is -1. 3, so simplified, it's -1 times -3 is 3, minus 0, plus, minus 2, which is equal to 1. So the determinant of A is equal to 1.
So now that we know our determinant and our adjoint, we can put them both into the equation and solve for the inverse of A. So let me get a new page. So A inverse is equal to 1 over the determinant of A, which was 1, times the adjoint of A, which was -3, 0, -2, 9, 1, 6, -1, 0, -1. And we know that 1 times any number is the same, so the inverse of A is just equal to the matrix -3, 0, -2, 9, 1, 6, -1, 0, -1. And that is our answer. Thank you all for watching our video. Woo! Bye!